Yeah, good morning, everybody.
Good morning, sir.
Okay, all of you can hear me. Okay, I've started the recording just for information purpose. Okay, and I will just share one PPT first. So today's topic we're going to be covering is the vertex. Yesterday we discussed a little bit about not a little bit, quite a bit about the great circle. Let me see how many people are there. Why there are only 16 people now?
So they are facing problem in my camera app.
That is not possible. That so many people are having a problem
Yes, sir,
with that.
nothing
Huh?
is being shown in their screen.
What is that? Nothing is being
Shown in their screen.
they're not able to see anything in their this app.
I can hear, yes, sir. They are discussing about it in WhatsApp.
But how come only the first year is having a problem? What about the second year, third year? They are not having any problem. We can see almost full attendance in the second year, third year.
Don't know, sir.
No, there is something else. I don't think it is with the internet, because even in the second year, third year also people are from remote places, and they all have the internet. And you all are having some of you are having very good phones, so I don't see any problem. Anyway, just please tell them join fast, whosoever has to join, because once I will mark the attendance, then I will be sent to course in charge and also to a DG. Okay.
Yes, sir, they are trying again.
Yeah. Okay, so okay, so this is what we are going to do today, and this. So what I will do, I will just start this. I will show you some movies actually. Okay, about the vertex. Let's see. One minute.
Vertex of a great circle. Let us assume that this is Earth, and Earth can be considered as spherical. So this is North Pole and South Pole, and this line can be assumed as equator. Now, suppose
So
this is
the video is paused.
we can define great circle as a circle which is having the center which is same as the center of the sphere. And as we saw, the great circle is reaching to a maximum point, and thereafter the latitude is decreasing. So the point where great circle reaches the maximum latitude is each great circle will have two vertices, one vertex in the northern hemisphere and one vertex will be in the southern hemisphere, and both these vertices will be 180-degree apart. If we examine carefully, if we are going from west to east, the course will be 090 degree, or if we are going from east to west, the course will be 270 degree true. So we can say the course is exactly east or west at the vertex. I can explain this. Suppose these meridians are represented as a straight line. So here, this is the course and of a great circle. In this video, I'm going to discuss about vertex of a great circle. Let us assume that this is Earth, and Earth can be considered as spherical. So this is North Pole and South Pole, and this line can be assumed as equator. Now, suppose this is a great circle. We can define great circle as a circle which is having the center which is same as the center of the sphere. And as we saw, the great circle is reaching to a maximum point, and thereafter the latitude is decreasing. So the point where great circle reaches the maximum latitude is called vertex. Each great circle will have two vertices, one vertex in the northern hemisphere and one vertex will be in the southern hemisphere, and both these vertices will be 180-degree apart. If we examine carefully, if we are going from west to east, the course will be 090 degree, or if we are going from east to west, the course will be 270 degree true. So we can say the course is exactly east or west at the vertex. I can explain this. Suppose these meridians are represented as a straight line. So here, this is the course, and the course angle is increasing, and at some point this is a 90 degree. Well, this point will be called as vertex. Why should you know the position of vertex? Well, ice, fog, extreme cold and bad weather are associated with high latitude. So in case this is the area you want to avoid, and you know the vertex where you will reach to this latitude, well, you can modify the passage and can avoid this area. The second reasoning of knowing this vertex is that you can easily calculate intermediate points, and that can be done by the application of Napier's rule, which is the rule for 90-degree triangle. Also, the position of vertex is very important, whether it is inside or whether it is outside in a spherical triangle which is formed by the pole and arrival departure positions. So here, this is course angle A and this is course angle B. Well, course can be different. Course can be from this. We're interested in course angle. So if course angle A and B are acute, vertex will lie inside. Acute means less than 90 degree. Now, if A is acute and B is obtuse, obtuse means more than 90 degrees. So let me mark here. Obtuse means the angle is more than 90 degree, and acute means angle less than 90 degree. Well, the vertex in that scenario will lie outside and it will be close to obtuse angle.
Hello, everybody. Were you able to hear the you were able to see the video properly and hear the sound? Just tell me yes in the chat, please.
Yes, sir.
Okay. So I hope it is somewhat clear what exactly is a vertex. It's not very difficult to understand. In fact, rather it is easy to understand what is a vertex. Now, I will show you another video in which we will see, like, how to calculate that vertex. There is something called Napier rules. Okay, let me just start with I will show you what the Napier rules are. Then probably we'll see the video, so it'll be easier, maybe easier for you to understand. Okay. Okay, you are able to see the PPT now? Is everybody seeing the PPT?
Yes, sir.
Okay, good. Yeah, somebody should reply yes or no or write in the chat so that I know what's happening. Otherwise, I don't know what's going on. Okay. Now, I will just straightway. Okay, let's start a little bit again. Now, vertex. This, yesterday also we discussed this, and also you saw in the video what is a vertex. Okay. So I will not take much time explaining these things. We already have done this. Okay. So this is all about the vertex. This is what he was talking about also. The knowledge of the position of the vertex is useful to the navigator for two reasons. Okay. If the latitude of the vertex is too high, the navigator may want to modify the course as he would like to avoid the ice, fog, extreme cold, and bad weather which are associated with very high latitudes. Okay. So that is another reason. And the knowledge of position of vertex helps in quickly calculating the position of any intermediate positions on the great circle track. Okay, so rather than picking up the points from that mnemonic chart, which is a great circle chart, we can also calculate, if you know the position of the vertex, then it becomes easier to calculate the intermediate position, like if this is the longitude, what will be the latitude. So all that can be calculated by, if we know this, the position of the vertex. And that is why it is important. Now, before we actually calculate the position of the vertex, it is essential to know where the vertex will be. It can so happen, like if we are in the northern hemisphere, like you start on a northeasterly course, on a great circle course, which is starting as a northeast course, but even your final course is northeast only. That means you have still not reached the vertex. That means you're still climbing up. Your downward, you have not passed that east-west course and not started to descend downwards. Okay, so by looking at, or by seeing at the positions, and how our initial courses and how our final courses, we can make out a little bit. But we will have to calculate the initial and final course. I mean, just by looking at the lat long of the positions, we cannot find it. Okay, so that is the. Okay, this is easily known by very elementary reasoning as described below. With just remember this. Text is from Captain Subramanian's book, so you can refer to Captain Subramanian's book anytime. You have the books with you, and okay, if both A and B are in the same hemisphere, these are the reasons. I mean, like different notes on this vertex. Like if
So we don't have the book.
then you have to do something, because don't tell me you left it in the college.
Yes, sir, we did.
Yeah, but then I cannot help it if it is there in the college. Okay, but you are supposed to be having the books. I mean, you have been given the book. If you're having it with you or no, that I cannot say, but you have been given the books. Okay. Okay. Anyway, but this is just for your reference that it is taken from Captain Subramanian's book. So, you can get it from there also. Or nowadays you can go onto the internet and you can check all these things. Very easy to find. So if both the positions, that is position A and position B, are in the same hemisphere, the vertex also will be in the same hemisphere. Okay? It cannot be in the other hemisphere. Although, of course, there are one of the this thing vertex might be in the other hemisphere, but the vertex that we are concerned with, that is on our course, or even beyond our course or beyond our position, that will still lie on the same hemisphere. Now, if the A and B are in the different hemisphere, the vertex to consider is the one in the same hemisphere as the higher of the two latitudes. Okay, that means, let's say if you are going some place from 20 degrees north to 40 degrees south. Okay, so the vertex that we will have to bother about is the one which is towards the south. Okay, which is occurring in the southern latitude. This is what it means, that if position A and position B are in different hemisphere, the vertex to consider is the one in the same hemisphere as the higher of the two latitudes. Okay, so I gave you an example. If we are going, let's say, from 20 degrees north and some longitude to 40 degrees south, then the vertex will be in the southern part or the southern hemisphere. That is what it means. Now, if the initial and final courses are different quadrants, like I said, the initial course is northeast and the final course is southeast. That means you have already passed the vertex, and the vertex was vertex was somewhere on the route AB. If you take the starting position as BA and the final position as B, then the vertex is somewhere along that route. Okay, that is what it means, that if the initial and final courses are in the different quadrants, that is, the vertex lies between A and B. If the initial and final courses on the same quadrant, the vertex lies outside AB. Like I said in the just now, like if your initial course is also northeast, let's say 045, and your final course, when you calculate on the great circle, is coming to 075 or 085 also, that means you have not reached the vertex. The vertex will be still, if you extend that course, that line AB. Extend, of course, not literally extend, but it will be outside that AB. Okay, that is what it means. Now we will take up this word example, but I'll tell you what now. Can you say which is the right angle? You can see that if we consider B as the vertex, then this angle, that angle PVA, that is the right angle. Everybody agrees? Just put down on the chat yes or no, or which is the right angle triangle? Which right angle triangle you are seeing? Yes, I got the answer from Safdar. What about the other people? Okay. Yeah, actually, just looking at it, we can make out like which is this thing. Chalo, good. Anyway, now, okay, this actually I was typing. Now, you see this angle V is the right angle triangle. Okay. So now let us make a circle like this, what is shown here. And we put you can write here 90 degrees. Can you see my cursor? Just say yes or no. Somebody can unmute and tell me yes. Okay. So if we write here 90 degrees, so which are the adjacent sides which are making that 90 degree? It is not PV and P. I mean, they are PV and VA, isn't it? Agree? Yes or no? Okay.
Yes, sir.
Write down the adjacent sides of that angle 90 degrees. Just write on that. Write in the chat quickly. Okay. Okay. So I hope it is clear to everybody that the two sides that is making that angle 90 degree is the PV and VA. Now in this case, what do we know actually? Do we know the V and A? No. Do we know PV? No. Because PV we have to calculate. That is how we will get this thing. Now, what do we know? Okay, what are the yeah. What are the things known in this triangle to us? Can somebody tell me? Or can you note it down? Can you put it down in the chat? What are the values which are known to us? Actually,
Angle V.
Pardon? Yeah, just speak up. No problem. Just say which are the values which are known to us.
Sir, angle V.
No, there are other things also known to us. No. In fact, if you look carefully, I'm already showing you there what all is available with us. If you look into the PPT properly, you will see what is written there and what we are saying. What are the known values, or which values are known? Yes, come on. Somebody should be able to give me the answer. See,
We
if you
know
can.
V
Pardon?
and side A.
Side A, we don't know. We know that PA, that is collat. If you see in this circle, there are two tick marks here. One tick mark here and one tick mark here. So these are the values which are known to us. Okay. So these values are known to us. If you say 90 minus A, how do we know? We know that because before we calculate the vertex, we have to know what is the initial course and what is the final course. Okay. So we know these values where you have the tick, and what we have to calculate is there is a question mark on this circle. So how we make this circle is that we put the 90 degrees here and we put the adjacent sides here and the opposite sides here, opposite side here. That means which is opposite to 90 is 90 minus PA, isn't it? Opposite of this angle is I mean, this angle is facing which side? That is PA. So that is 90 minus PA. And then here 90 minus A and 90 minus P. Okay, that PV, see, this PV side is the opposite angle is A. So here we put 90 minus A, and opposite of this we put here. Okay, now VA is angle P. So we are putting here an angle 90 minus P. Okay, like, okay, I should have put 1 minute, I cannot. Okay, anyway, we'll see the video also. That will make it clear, because if we write here 90 degrees, so this is the angle, what is the side which is opposite to that? So opposite to 90 will come here. That is opposite to 90-degree angle is the PA, so that 90 minus PA comes here. And the other two sides come here, and the sides which are containing that angle 90 are here. Okay, like you can write VA here and PV here. In that case, this also will be, interchange. That is all. So this is what the way to make the this thing, Napier rule. And once we have made this circle, then we have to apply this formula for, there are only two formulas in the Napier rules. Sine of middle part is equal to cos of opposite part, and sine of middle part is equal to tan of adjacent part. So then applying those formulas, we can calculate anything. If I want to calculate, let's say VA, where my cursor is, if I know these values, tan of adjacent parts, I can calculate this value. Or let's say if I want to calculate PV, I will take, opposite parts. Opposite parts are 90 minus P and 90 minus A. So that will give me the sine of PV will be equal to opposite of 90 minus PA and into opposite of 90 minus A. And that is what is given here. Okay. So this is basically the Napier rules. Now let's go back to the video, so that, you will be able to understand maybe more looking at the video. Let me just stop sharing first. Okay.
Spherical triangles, because we've introduced now the vertex, the point of maximum latitude. PV is our maximum. Were you able to hear the video and the sound?
No, sir.
No, initially when I started. No, when I started it.
Yes, sir. First time we were able to.
Okay, I'll start again. Yeah.
Sir, can you send us the links of this video?
Just 1 minute, because
equals tangent of adjacent parts. And I've put in red there the two A's to remind you if it's tangent, it's adjacent. Okay, we're going to look at Napier's rules now for what has now become a right-angled spherical triangle. So in the previous great circle problems, we were simply looking at a situation where we had a spherical triangle. Now we have right-angled spherical triangles because we've introduced now the vertex, the point of maximum latitude. PV is our maximum latitude. And the two basic formulas that you need to remember, sine mid-part equals tangent of adjacent parts, and I've put in red there the two A's to remind you if it's tangent, it's adjacent, and sine mid-part is cosine of opposite parts. So again, two O's, cos becomes opposite, and we both start off with sine. So it's sine mid-part equals either tangent of adjacent or cosine of opposite. So just remember tan, sine, tan, cos. Tan is adjacent, cos is opposite. They're the only three values you've got, cosine, tangent, sine. So the first one is sine, tan adjacent, cos opposite. And if we look at a diagram there, that's PA, of course, which is 90 degrees plus or minus latitude, PB 90 degrees plus or minus latitude, PV is 90 degrees minus the maximum latitude. So we know that value there, we know that value there, and we know that value there. We know those three values. So if we draw the wheel for Napier's rules, there's the wheel there, and we've got PV, VA, P, PA, and A. And I've circled the known values. Okay, so we know those two values. And if we wanted to find the A, the initial course, which is this one here, then what we have to do, we have to say, okay, we know that one, we know that one, we don't know that one. So we need to involve those three in the formula. And we can see that sine, the mid part, excuse me, equals cosine, the opposite parts. So in this instance, PV is the mid part, and PA and A are the opposite parts. If we had the values P and VA, they would be the adjacent parts to PV. But PV, these two are opposite, so they're the four values we would use. And incidentally, when you're using Napier's rules, always use the two values that you know, because if you use a value that you've calculated and you've made an error, of course, everything else gets thrown out. So always use the values that you know. So to find the initial course, we'd use those two, and we'd say that sine PV, and now it's cos co PA and cos co A, because they're below the wheel, of course. So sine PV, because it's cos co both those, they would convert to sine PA times sine A. And we want to find sine A, so sine A would be the sine PV divided by sine of PA. It would be useful to get used to doing this mathematical changing of the formula to get your confidence going with Napier's rules. When we're solving the final course B, what I've done now, I've changed VA to VB, and I've changed PA to PB, and of course A to B. The wheel's exactly the same, but I've just put now my two known values as PV, of course, and PB. And we're looking for B, which is the final course. So we're doing the same thing here. These are the two that are involved, plus this one. So this is our mid part, and these two are our opposite parts. So it's exactly the same as we did initially to find our final course. So using the wheel, if it was this value, those two would be opposite, those two opposite there. Okay? Now, if we're trying to find the distance A to V, okay, A to V, then these are the two values that we know. A to V is what we're trying to find. So in this instance, we'll use PA as the mid part, and these two are opposite parts. So I hope you can see that. We know these two values, we're trying to find that one. So PA becomes the mid part, and of course that's sine co now because it's below the wheel, and these would simply be cosine PV and cosine VA. And you would simply, doing as I've done there, change the formula around, and you get cosine VA is cos PA over cosine PV. Then we'll look at finding the D long P, which is in effect APV. Okay, so we're looking for P. So that's this value here, P, and we know PV and we know PA. Okay, so in this instance, they're adjacent. So in all the previous ones, they've been opposite, but this one now, P is adjacent to this, so it's tangent. We're going to use tangent now. Now that's going to be sine co P is equal to tangent of PV times cotangent or tan co of PA. And again, we'd have to move the values around. Sine co P becomes cosine P. Tan PV times 1 over tan PA. Therefore, cosine P is tan PV over tan PA. And we do exactly the same to find the distance BV and the D long B PV, just as I've done there now, by using the second wheel that I've drawn. Everyone has different ways of solving this problem, of approaching them, I guess, really. We all have the way we find is a useful way. I find drawing the wheel, two different Napier's wheels, I find it easy to do it that way because I've changed the values from A to B, and then when I look at them mathematically, I can see what I should do. But the important thing to remember is always use the two values that you know. Always use those to find the third value, because on the wheel, as long as you know two values, you can always use those to find the third value that you're looking for, regardless of which one it is. So whether you're looking for A, VA, or P, by putting any of the two that you know with this third one, you can always solve the problem. So always use the two known values and you'll be able to solve using Napier's rules. But just remember, sine mid, it always starts off at sine mid equals tan adjacent, cos opposite. Tan is A for adjacent, cosine opposite. And just get used to the wheel. Again, it's just practice, looking at it and working out the relevant information.
Okay, can you hear me now?
Yes, sir.
Sir.
Yes, sir.
Were you
Yes, sir.
able to understand like what exactly is happening? Anyway, we will do it again tomorrow. I will show you in the PPT. The basic thing is that, you know, you should be able to make that wheel or circle or whatever you want to call it, and how to place the sides, you know, which will go there. That is important. Like where you're putting those PA, PV or AV, AP or whatever. If you have put them correctly, and then there are only two formulas involved. That is, you know, the sine of mid part is equal to tan of adjacent part, and sine of middle part is equal to cos of opposite parts. So what is important is that you should be able to put all those values properly and just somehow figure out, like, you know, which values are known and which values you have to find out, and somehow, you know, get them into those, fit them into formulas, like by which one to take as a middle part, so that you are able to find out the, you know, whatever is required. So that is what is actually about the Napier rules. We'll just go. I'll just go through it again. I'll share the PPT with you again, like how we are doing it. I'll try to make a little more this thing, because what I feel is, even in this YouTube video, you know, maybe the sound or probably people are not able to understand him properly. So we'll go through the PPT and then we'll try to solve one of the examples there from the book, and then I'll give you some questions to do it yourself. The important thing is, if you noticed in that wheel that he is making, that you know, he's saying we know the angle A. So remember that we have to calculate initial and final course beforehand. Okay. So we have to know what is the initial course and what is the final course. And, you know, like they are taking the angle PAV. You can also take, you know, PBV. You know, any one side you can take to calculate the vortex. Okay. So any questions for today's lecture? Anything you need to ask? Anybody?
Sir, can you send these links. YouTube
Which
links.
links? Huh? YouTube
These
links?
YouTube videos.
Okay, I'll just show you the PPT again, and you will be able to see the links. Now you just take a, this thing. Okay, you are able to see the link now?
Sir, I cannot see PPT in your lecture.
You cannot see the PPT. Okay, 1 minute. 1 minute. Can you see the chat? Are you able to see the chat?
Yes, sir.
Okay, I've just put one of the link there. Or okay, I will give you the links on the WhatsApp group. Okay, I will put the links on the
Yes,
WhatsApp
sir.
group. Okay.
Yes, sir.
Any more questions?
No, sir. No, sir.
Okay, so it's about time. You might be having some another lecture. So that is all for today. We have a lecture tomorrow also, no? Same time.
Yes, sir.
Yeah. Okay. So tomorrow I'll try to finish this topic so that at least you can practice something at your end. And okay. So okay then. Have a good day. I'm stopping the recording now. Okay.
Yes.